Okay, so I'm pretty much just I'm just finding the integral of ln x using uh, integration by parts. Integration by parts. I might do the DI method, but I think I'm just gonna do it the traditional way first. So if if I remember correctly, I am pulling this from the top of my head. The integration by parts formula should be UDV equals integral UDV equals y, uh I think it's UV and then VDU. This yeah, so integral UDV equals UV minus the integral of VDU. I think that's it. So I'm gonna do this the way I was taught it. So my teacher's YouTube right now. I'm not currently in school. Gonna be there in a little bit. So yeah, so the way I was taught is we're gonna do um we're gonna have u equals whatever, and then we're gonna have du, the derivative of u. We're gonna have dv, and then we're gonna have v. So dv from dv to v we're integrating, and so that pretty much means it can't be ln x because we're already trying to integrate ln x. So that's off the charts. So ln x has to go here. And we're pretty much we're just for dv, it's just going to be dx. Bam. So then we'd integrate both sides on here, and then we just get x. Crazy. The derivative, did I say derivative of this? I integrated that. Yeah. The derivative of ln x is just 1 over x. Very cool. And so we're going to look at this formula right here. We're going to do u times v. So we have ln x times x. So here we have x ln x minus the integral, right here, minus the integral of x times 1 over x. So if we have x times 1 over x dx, I think you have the dx there, I'm not 100% sure. Either way, 1 over x is just x minus 1, right? So these guys cancel out, and we just get 1. 1 dx. I think that's how you'd write it. Which then, the integral of 1, or just, the integral of dx is just going to be x. So our answer is just x ln x minus x. And I think because we're doing an integration thing, we have to have the ln x within the absolute value symbols, and then of course add our plus c. I definitely didn't almost forget about that. Of course, why would I? I think that's it, unless I got it wrong. Then yeah, I'm kind of feeling it, so let's do another one. So here we have the integral of x squared times sine x dx, and I wrote the integration by parts formula right here. So, what do we want for u, and what do we want for dv? So it would be nicer if we integrated sine x instead of x squared. I feel like that'd be nicer. So let's do exactly that. Let's do exactly that. So we're gonna have x squared over here, and we're gonna have sine x here. Okay, I usually forget. Like sometimes I do in derivation. It's late. No, don't know how to say it anymore. Sometimes I'll derive this instead of integrate it. So the integral of sine x is just negative cosine x. Negative cosine x. Very cool. Not the integral, the derivative of x squared is 2x. And we're just gonna do u times v, because we says it right there. So we have u times v would be minus x squared cosine x minus the integral of cosine x, no, not cosine x, but negative 2x cosine x. There you go. Dx. Actually, I don't know if I still don't know if you have the dx. And as you can tell, we gotta do it again. We gotta do it again because this also requires integration by parts. So we have u equals whatever, and then du equals whatever, dv equals whatever, v equals whatever. And we're pretty much gonna do what we did last time. So we have our negative cosine x, because it'd be nicer if we did that instead of integrating 2x. And then we're just got negative, not negative 2x, because the negative is part of the cosine. We gotta remember that the negative is part of the cosine. So I have 2x, and then the derivative of 2x is just 2. Yeah, I don't know how to think about that, but just to make sure. And then the derivative, not the derivative, the integral of negative cosine would be negative sine x. And so I'm actually gonna write it on this side this time. We have this will make a plus, because we have a minus minus. This will be a plus. This will be a plus. Very cool. I think we'll work that out once we're done with all the integrating by parts. So we'll do the uv. Our uv would be I'm gonna write it over here this time. So we have negative 2x sine x, negative 2x sine x, and then we do the v, do the minus the integral of v times du, so that'd be negative 2 sine x, negative 2 sine x. And as we see, we have to do it again. Sick. Gotta love it. We gotta do it again. So within this integral, we have another u, another du, another dv, and another v. So of course, for like same reason as last time. Hold on, I'm gonna do it like this. It'd be nicer if we derive the 2, and it'd be easier if we just derive the 2 and then find the integral of negative sine x. So we have the integral negative sine x, which will just give us cosine x. And we can check this because we can check if this is correct. We can ask ourselves, what is the derivative of cosine x? And that would be negative sine x. And it's negative sine x because it starts with the c. And all derivatives that start with the c give you that negative, like cotangent, stuff like that, cosecant. And now we have 2. And then the derivative of any constant is just 0. And so now I know at this point we're not gonna have to continue anymore for integration by parts, and we can just, we can just keep it going. So we have 2 cosine right here. 2 times cosine. 2 times cosine would be, 2. We'll do it over here. 2 cosine x, and then minus the derivative of 0, which is 0. Crazy. So now we're gonna work out these bad boys right here. And so here we see we have a negative and a negative. So we're gonna distribute this negative in here. That gives us a plus and a plus. Happy times. Here we have a negative and a negative. We have a plus and a plus. Happy times. Very cool. So this should give us the final answer of negative x squared cosine x plus. So I'm watching the video where I got this question from, which is like the organic chemistry teacher, right? And in the end, we got the same thing, except this term right here, I think this is a term. This term right here, it's a plus and not a minus. So I pretty much did get the entire thing right. It's just this symbol is wrong. Sine x plus 2 cosine x plus c. So like this is the final answer. I'm just not sure where I got wrong with this, with the negative there, but I still did it. I think I still did pretty decent, all things considered. So yeah, if we want to take a look at the DI method, we could just do this, right? And if we look at the DI method, we gotta look up here. What do we want to integrate? Let's integrate that sine x. And what do we want to derive? Let's derive that x squared. Let's see if we have enough space to do it here. So let's derive this x squared. Plus, remember to write your plus minus. This is the DI method. Oh, I don't think we're gonna have enough space. We'll try to write really small. And then we'll have sine x. So if we derive x squared, we just get 2x, and then we just get 2, and we get 0. And then for I, or the integration area over here, the integral of sine x is negative cosine x, and then the integral of negative cosine x is negative sine x, and then the integral of negative sine x is cosine x, and then we simply just multiply, and then, you know, we do the multiplication here, but it doesn't particularly matter for that spot because, you know, cosine times 0 is just gonna be 0, right? So it doesn't matter. And then we'll get this answer too. And yeah, from here I can definitely see, I could see why this is a plus and not a negative, like how I got it up here, because there's a negative here and there's a negative here, they cancel out, so you get, you know, the positive 2x sine x. I don't know, I fluffed up somewhere, I'm not sure where, but yeah, that was integration by parts. Pretty fun. Whoa, pretty fun, pretty cool. Gotta love it. Gotta love math. Gotta love math. It's 12:13 right now. I should probably go to sleep. And yeah. Good night. Quick little note. I now know why this is a plus, not a subtraction. Yeah, this is me like 10 minutes later after I'm like watching the video and editing it and all. So now I know why this is a plus. And it's because it's simply because this part is just that. This is that. This thing is that thing. Just, you know, the work is done and it's simplified. And it's a minus and minus, and because this is just that, the, you know, the, don't worry about don't worry about my phone. The negatives just how you say, they cancel out and then you get the plus, and that's why this is a plus and not a minus. So yeah, fun. That's probably why I might do the DI method more in the future instead of the traditional method. But I like the traditional method. It's very fun and cool. Yeah. Thanks for watching again, and bye bye.